Hello, everyone, and very welcome to this press conference. So we'll begin with just taking questions for the laureates, and then there are some scheduled interviews, private interviews, but we'll see and start with questions, preferably in English. If there are questions in Japanese, for example, we'll take them last. Any question? Any of the laureates? Here we have one, yes? Please? Yeah, go ahead. Microphone. Yeah. Here.
Thank you. David Keaton from the Associated Press. You have now had 2 months to let this news trickle in and really make an impact. Can you tell us how you feel now, 2 months in, about winning this prize? If you could each tell me how you feel about this, and now that you've had time to think about it, what legacy would you like this prize to be for this specific, for the research for which this prize has been awarded? What legacy do you see in this prize?
Who wants to start? Mary, do you want to say a few words?
Well, so the initial reaction was complete surprise for me. And so I would say 2 months later, I'm a little less surprised. That part has sort of worn off, but I am even more humbled and gratified by what the prize means, or what the work that's being honored by the prize means, because I really do see the huge impact that it's had on coming up with ways of treating human illness, which is, it doesn't get any better than that. So I guess that would be the legacy also, is leaving opening path to better treatments.
Maybe Professor Sakaguchi, you want to say something?
Well, since I got notice over telephone from Dr. Palman, it was really a pleasant surprise for me. And since then, I have been overwhelmed by the interviews and the interviews by media people, and invitation to the government, to the Congress, and also the high schools to say something to young people. So it has been very busy 2 months for me, and then now I'm here, and then I really hope to enjoy this Nobel week this week. So then I hope that the receiving this Nobel Prize, our society will recognize that the importance of medical sciences, medical research, and then also I told the government that, well, it's important to support the basic sciences, and then so lots of interaction with people and the government, and then especially young people in these 2 months.
Okay. Yeah, go ahead, please. Answer.
So I kind of echo the sentiments that the shock has worn off, the surprise and the humbleness, and I think just the existence of the award is still. I'm still struggling with that, because it's kind of amazing and was completely unexpected. And in fact, I didn't even hear about it for 12 hours, as most of you know. So I was one of the last people. Everyone in this room probably knew before I did. But I will say, the other things that have really stuck with me in the last couple of months is the outpouring of support from my friends and colleagues. It's just been tremendous and amazing, and I've been really blessed to have great friends and colleagues over the years. and this just highlights that. And I think I'll echo Shimon in my comments about the legacy, which is I certainly hope the actual prize discovery leads to therapies for people, and we're clearly working on that, and I feel optimistic about that. But I think the bigger issue and the bigger legacy aspect for me is that people recognize the value of basic research and supporting things that may take many years and a lot of time to come to fruition, and continuing to support that from the government on down, I think is something I hope that this prize will remind people of.
Please, Polish television. Yeah, microphone up.
Thank you very much. Bogdan Radeski from the Polish television. First of all, warmest congratulations to all of you. And I have a question, first of all, to Professor Sakaguchi, because in 1995, when you published your work, it was the scientific consensus that, well, we've got the immune system and immune tolerance basically sorted out. Yet you decided to go against the crowd and investigate other possibilities. So what made you do that? And to the other laureates, how important was that work in your research that you've conducted a few years later? Thank you very much.
Well, we identified, characterized the regulatory T cells as with definite marker. That was 1995. Since then, before then, the suppressive phenomena is well known. And then what we showed is that definitely there is a regulatory T cells as definite cellular entity. And then the people can, everybody, every immunologist can deal with it with definite marker. And then it really facilitated the progress of the research in Treg. So that was perhaps our contribution to the field, and so it has been kind of fun to see how they use that marker, and then characterizing that population, and then showing how they are important in various disease settings, and organ transplantation, and then also cancer immunity. So that was really a fantastic years since then, at least for me.
Yeah, so just to highlight Shimon's discovery even more, I was in graduate school when people were talking about suppressor cells, and the field essentially fell apart in the mid-'80s for a lot of reasons. And Shimon didn't stop, and his work was absolutely seminal and convincing, unlike a lot of the previous work. And so people believed they were there, but we didn't really understand, how important they were in humans, for example, and weren't really good handles for them from a molecular basis, et cetera. And so when we found out the FOXP3 gene was basically only in those cells, it was the ability to marry the molecular biology with the cell biology that Shimon had pioneered. And so without all of that work, and without his, I will say, stubborn nature to pursue those cells and prove to the rest of the immunology community that these were important, we would have been had a much harder time. And that was just key in our ability to bring these two things together.
Yeah, I don't have much to add to that, except that my participation in the project was really from the point of view of the gene finding process, so using mouse genetics and molecular biology to identify the FOXP3 gene. And so it was naturally very exciting and satisfying to find that after all of that work, it turned out to be something that was so significant as a marker of the cells that Dr. Sakaguchi identified. So it was, as Fred said, a nice combination and converging of different approaches.
Please.
Hello, I'm Corina Negra from Radio Romania Science Department, and I have two questions for Professor Ramsdell. First of all, do you think that nowadays in the US it's still possible to have that kind of basic research, attitude to basic research, like the one you experienced? Because nowadays there is a huge pressure from the funding point of view. So you are running to get funds for basic research. And secondly, we now have CRISPR, so we have gene editing technologies. Is there any danger for these techniques to alter our immune system in the end? Because what you get after editing is different than it was in the beginning.
Correct. So let me do the latter one first, the CRISPR comment. So there's always some level of risk as new technologies become online. Right? And there is CRISPR, but there are versions of CRISPR. And the more we learn about it and the more advanced we get, the safer those become, the less off-target editing there is, for example, and things like that. So yeah, I think that's always a concern. Do I think it's a general concern? I do not. I think that there are ways we can understand how well we've edited and not edited. There are controls where we can control to a large extent the amount of editing, what cells are edited, how it works, and we'll understand that editing. So do I think there's a risk? I think there's a minor risk. There's always a minor risk for some of these things. But I don't think it's anything that should or will slow down the continued use of gene editing to make better therapies, et cetera. In terms of the funding, so what Mary and I did, we worked together at a small biotech, and biotech funding for research of the nature that we did, I think, is very rare in the United States now. Most companies, even the smaller ones, are focused on more translatable biology. We happened to work for an organization at the time, back in the 90s, that had a very long-term vision and was willing to support a long-term vision, using genetics, mouse, human, and otherwise, to understand biology and try to then be able to take that to a therapeutic level. Most companies don't do that. Basic science is really supported largely by the federal government and from nonprofit organizations. Clearly there is pressure around those right now in the United States. There's been other times when there's been pressure on those things as well. This is maybe different than those in some respects, and I'll mention that in a second, but it's not the first time that that's come under pressure before. So I do think it's a challenge. I don't think it's gone away. It's not as though basic research has stopped in the United States. That's not fair to say. But I think it's something we as scientists, in my personal view, need to make sure we can communicate to the population, regulators, politicians, whoever wants to listen, about how valuable putting in the research at the basic level is to downstream effects on human health and human biology, and frankly the economy as well, if we want to make an economic argument about it. So I think we have work to do, but I'm optimistic that we will get through where we are today and come back to a place where we'll still support basic research.
Okay. Any more questions? Yes, please, go ahead. Yes.
Thank you very much. This is Kazuhiro Fujitani from the Asahi Shimbun, Japan. And some people might have slightly surprised at this year's Nobel Prize because regulatory T cells are still in the process of being translated into clinical applications, even though it was great discoveries with no doubt. But I wonder what your reaction was that about you got the prize at this stage of this research. And the second question is that what kind of future development in this field do you expect as a result of this prize?
Well, my understanding is that this year Nobel Prize it was for peripheral immune tolerance. That is an important notion in immunology. How the immune responses against our self-constituent, how it is prevented or suppressed. So that is basic immunology. And then it has, but it's close to the clinical immunology. So my understanding that the Nobel Committee or Nobel Assembly, they appreciated this basic research. And then your second question about the clinical application. So immunology is a very interesting scientific discipline in which the basic science and the clinical science is very close. If you find something as basic immunology, and it can be easily translated to the clinic. But of course, make developing a new treatment, a way of disease prevention, it may take time, but it looks like it's still an early stage for clinical application. But we are optimistic that someday the Treg-based therapy, various immunological diseases or transplantation or cancer, they all become real in the clinic.
I could maybe just say something about the Nobel Prize since I'm a representative of the committee here. It's the prize in physiology or medicine, and it's always been interpreted as that a prize can be given for very basic discoveries and also very much translated discoveries relating to treatments and therapies. In this case, exactly as Dr. Sakaguchi explained, there was knowledge about tolerance in the immune system, but it was incomplete. Here's a discovery of an active process, not a developmental process that was known before, an active process going on all the time in our bodies to actually regulate and keep the immune system in check. And that is a basic fundamental discovery in physiology. And of course, it has profound clinical implications as well, as we know. But the prize is really for a very basic discovery of great importance and with implications for the clinic. Sorry for... No. But anyone else want to add to that?
The only thing I would say on the clinical side is obviously, you probably know, there are clinical studies ongoing by a number of groups trying to harness the principle, sometimes the cells, sometimes the principle already. And it's very early days for those trials, but I would also suggest that many medicines require iterations and starts and stops to actually get the right drug and or the right setting, etc. So I think there's still a lot to be done, but I'm very optimistic that this will work in the long run.
Here's one more.
Hi.
Please go.
I'm Jonathan Klein from ASP. Just wanted to know, you touched on that already, Dr. Romser. How worried are you with the research in the US with the Trump administration at the moment, and why your research are so important?
Well, so I mentioned this. I am most worried in the United States, to be honest, about how well we as the science community have communicated what we do, the value of that, and in the time frames, et cetera, of how useful it will be. Because if people don't value something and don't have trust in what you do, then you're not going to get any funding. It doesn't matter. So I think that we in the scientific community need to be better at communicating what we do, why it's valuable, what progress we've made, et cetera, where things are. So it's not so much the current administration. I mean, we can talk about that a lot, and I really would prefer not to. But it's really much more for me about ensuring that people believe that what we're trying to do is for the betterment of mankind, as the Nobel Committee would say. And we just need to be better communicators of that, in my opinion, and find a way to actually be effective in our communication. And that's something that I think we need to work on a lot.
Good. Any more questions? Or I know we have requests for interviews. I don't see. Yeah, here's one more question. Yes, thank you. Please go ahead. And please introduce yourself.
Thank you. I'm Kazuhashiguchi from NHK in Japan. So I want to ask to Professor Sakaguchi. So you have established a venture company, RegCell, to pursue the practical application for regulatory T cells. So could you please tell me the long-term goals once again? 日本語でも言っていいですか？今 T-REX 細胞の実用化を目指して今やってると思うんですけれども、ベンチャー企業等を通して今後達成した目標とかをお聞かせいただければと思います。
So we decided to start a kind of startup company based on our basic research. It was 10 years ago, and then why we started that kind of company. That was we have been studying the T-REG with public funding, mainly from the governmental funding for many years. And now, we decided, well, it's time to apply the basic knowledge to the clinic, to treatment of real human diseases. The funding from the government, it's usually short term and then not much amount, but it may cost a lot to do clinical trials. So that was the main reason that, well, then we'd better start the kind of company and then recruit the funding from various sources. So that was what we have done. And as a prospect, we do believe that that way of facilitating clinical application, it's very active in the United States. And then we decided that our company from Japan to the United States because it may be better or much easier to do clinical trials in the United States because of society is more supportive in the United States compared with Japan. So that's my answer to your question.
Thank you very much. This is Yusuke Hara from Kansai Television Japan. So, a question for all three of you. So, how have T-REGs affected cancer treatment so far? And how do you think cancer therapies will change in the future as we learn more about T-REGs?
Maybe Dr. Branco?
Yeah, so the cancer therapy question is a great one. So it's very clear that certain types of cancers use and recruit regulatory T cells to prevent the immune system from recognizing them and destroying them. Ovarian cancer being one, but there's other examples of that. So there are a number of groups that are now trying to find ways to locally or temporarily to either eliminate or disable regulatory T cells in the context of a tumor. In mouse models, that clearly can facilitate T cell rejection of a tumor. Whether that happens in people, I think we'll find out in the next few years as the data comes through. There's multiple ways to think about how to do that. Clearly, you can't get rid of regulatory T cells completely and for a long term from the body, because we know what that looks like in humans, and it's not good. It's lethal, in fact. So it's got to be done in a way that is constrained to the tumor one way or another. But there are ways to think about doing that, and there's many groups doing it in various different ways at various levels of clinical study. So it's ongoing. It's not going to work for all tumors. It's going to work for some. But I think it will open a new door to certain types of tumors once we figure out what the right technological way to approach those cells are. You know, in terms of the long-term effect of regulatory T cell biology and what we're going to learn, how we're going to apply that, certainly in autoimmune diseases. Dr. Sakaguchi's company, I have a company, it seems like everyone has a company now, to try to utilize these cells to help treat autoimmune diseases. And again, very early days in the process of that, and multiple different ways to come at that approach. So I think as different technologies, data comes to bear, we'll actually figure out what becomes the best way, or if there's even a best way. There may be multiple ways that work in different settings. So again, it's very early days, but I think in the next couple of years we'll have a really decent handle on how best to approach that and apply it to autoimmune diseases. So we're not too far away, I guess is my message.
And I don't have a lot to add to that, except that I don't have a company. And in fact, my expertise is not really in the drug development and application of Treg cells. I really can't speak to that, but as more of an observer of what's happening in the field, I find it very encouraging that there do seem to be, kind of a multi-pronged approach to attacking these different kinds of disease areas, so autoimmunity and cancer and transplantation. And I think because the system is so incredibly complex and also very personal, I think in different diseases and in different individuals, that there's not going to be a one answer or one way to treat any of these diseases. And so I think it's very encouraging that the field has opened up so much and so many different approaches are being applied, and I have great hope that the innovations that are coming from multiple sources are in the end going to one by one start making huge differences in these different disease areas.
Well, so the cancer immunotherapy, it has been recognized to be effective. As you may know, Nobel Prize for Physiology or Medicine, it was awarded 7 years ago to Jim Allison and then Tatsuko Honjo. But we know that the effectiveness of current cancer immunotherapy, typically immune checkpoint blockade, it's effective only at 20 to 30% of patients. So there are lots of things to do. And then one thing we can do, that is targeting Treg, reducing Treg number in the cancer tissue. And then, so by various combinations, so immune checkpoint blockade to strengthen the T cells attacking tumor cells, and removing regulatory T cells, suppressing that kind of the anti-tumor immune responses. And then a cancer vaccine to facilitate or stimulate the cancer destroying T cells. So all these combinations together, I do believe that even current the cancer immunotherapy can be improved to say 50% effectiveness, and then in the future, and a better way of controlling regulatory T cells, and then controlling effector T cells, destroying cancer cells, all these together. And then we really hope, and then we are optimistic that the, well, not majority, but substantial fraction of human cancers can be treated by cancer immunotherapy. That is really our hope.
Okay, I think maybe it's time to. Okay, we'll have one last question up here. We'll start up here.
Okay, sorry. Hi, I'm Yukiko from Nippon TV. There are not many opportunities that three of you are together, so I just wanted to ask to Mr. Ramsdell and Ms. Brinker, well, how do you evaluate Mr. Sakaguchi's work, and sort of was it a surprise that he won, and vice versa, Mr. Sakaguchi, how do you evaluate the other two's work, and was it a surprise?
How do I evaluate Shimon Sakaguchi's work? Seminal. Without that work, none of us would be sitting at this podium. Obviously, he wouldn't, but neither would Mary and I right now. So, absolutely critical, not just for this prize, but for immunology in general. The immunology community, I think, didn't have a good explanation for something that the committee gave a Nobel Prize to in 1960, which was for some of the tolerance work that went on. We now have an answer, and a lot of that is certainly dependent upon and revolves around the work that Shimon and his group did back in the mid-90s. So key to all of what we've done. Absolutely.
More praise for Dr. Sakaguchi from Dr. Branco, or? Yeah, okay.
If you look at the literature, the number of publications about Treg or FOXP3, it's very suddenly goes up from the around the year 2003. So why? That was because we found that the CD25 as a good marker for defining Treg. And then Mary and Fred, they discovered FOXP3 in the year 2001. And so then cell surface marker and intracellular marker together, and then definitely now we can define regulatory T cells. And then especially the discovery of FOXP3, it's really recruited many molecular biologists into the immunology field. And then the publication abruptly or suddenly goes up. Now about more than 2,000 reports per year last year. So the Mary's and the Fred's work is really the kind of crucial finding for Treg research.
And I would just echo again what Fred says, just the long-term literature that is attributed to Dr. Sakaguchi is overwhelming. And even just, I mean, in the last few weeks, there were a couple of big papers, I think, that came out. So, I mean, I think in contrast to, you know, what we could do in a small biotech company, especially one that didn't stay in business past 2004, you know, Dr. Sakaguchi's contributions to the field have been, you know, over decades and continue to be really important.
Well, I'm more senior than these two people.
It's very rewarding for us to hear that the Nobel laureates agrees with the committee. So there was one. We'll have this as a final question. We need to move on.
Thank you very much. Kazuhiro from the Asahi Shimbun again, and I asked about the clinical applications. So apart from clinical applications, what do you think is the significance of awarding the Nobel Prize of your research in the field of immunology? In your point of view.
So setting aside all the clinical research and clinical implications of all of this, we now understand much more about how the immune system regulates itself. Its primary purpose for all of us is to protect us from pathogens, viruses, bacteria, etc. But we've always known that it had to do that at the same time, not destroying our own tissue. And it has the capability to do that. People who have arthritis and other diseases know that quite well. So what this award recognizes is now a fundamental understanding of how that balance occurs and how the body is able to still protect us from pathogens and yet, in most cases, for most individuals, not result in a disease where the immune system attacks us. And so getting a handle on the fundamental principles of how that happens now allows us to actually dig much deeper into how the immune system is formed, generated, and is controlled. And so you can think about applications for both cancer and autoimmunity, but it's even broader than that in terms of just tissue homeostasis and other factors that these cells are involved in. So it's really the cell type and the discovery for which the award has been given has really changed the way people think about how the immune system works in terms of physiology overall.
I don't have anything to add to that. That was well put.
Well, so Fred already told you the important how TILs are important. And then one thing, if I can add, that is for treatment of immunological diseases, and there are lots of the good drugs, immunosuppressive drugs, the steroid, of course, and tacrolimus or cyclosporin A. But Treg, we think that Treg are present in our body, so manipulating or the targeting Treg is more physiological way of controlling immune responses. And then also in the clinic, it's their cells, a living drug. And so we do believe that it's a new way of treating the immunological diseases. And then we hope that so they are physiological, they are present in our body, and they just subtly increase their suppressive function or decrease their number or function. And then we believe that the various immunological diseases, including autoimmune diseases, allergy, or inflammatory bowel diseases, so the application is very broad. And then we really hope that we are optimistic that we can contribute to clinical science or for the clinic.
I think we have to continue from here. So thank you so much for questions, and thank you to the laureates for all your insights and answers. And now there will be a few additional interviews. Yes, so if those who will have interviews in English, if your interviews will be outside this hall, and interviews in Japanese for Dr. Sakaguchi will be inside here.